Welcome to the first edition of the class about cloud computing for the master degree in computer science, machine learning, and big data. This first slideshow is about an introduction about cloud computing. Of course, in this slide, we will view many aspects that will be studied in depth in the following classes, in the following lessons, but it's just a way to give you a primer in order to teach you how to navigate in the cloud world. First of all, some prerequisites. Of course, you should make sure these prerequisites because you are attending a master degree in computer science, but in any case, you should be technology addicted. And of course, we are using an innovative way to make lectures. And a little bit daredevil as in learning new technologies. And even because these kind of technologies are mainly practical, but there are some theoretical issues. Of course, I assume you are touch friendly with any kind of computer tools, and in particular with networking and operating system. You should bring your own device. That means, especially because we are recording these classes using remote teaching system, but it's possible that you have a Windows provided laptop or a Linux provided computer or a Mac provided computer. For Windows and Mac, you already have the shell, while for Windows, you should have a terminal emulator. Actually, maybe the new version of the Windows shell already has SSH. That means if you have Windows 10 Pro, you should not use POTTTI, but just PowerShell. It's important if you have a Windows 10 Pro, Windows 10 Home, you should try to upgrade to the Pro because some tools like Docker doesn't work on the Home edition of Windows. In this first slideshow, we have just an introduction to the technologies. The definition, this is the formal definition. You can find this definition both on the NIST, the Institute of Standard Technologies of US, but even on Wikipedia, of course. Cloud computing is an on-demand availability of computer system resources, especially for data storage and computer power, but not limited to, without the direct active management by the user. What does it mean? That means that everything could be cloud computing if the computational resource, where computation means actual computing and data storage, is done on demand. On demand means there is a provider of resources and the user directly or indirectly interact with the resource in an elastic way. That means the key word for cloud computing is elasticity and scalability. Really often, large clouds are distributed over multiple locations. This is done for several reasons, for natural disease or natural disasters, or disease spreading, or even for some law-related issue about privacy and data protection. For the first time in this kind of classes, we will talk about another kind of peculiar application of cloud computing, that is edge computing. In this case, part of the computation is offloaded by mobile device or IoT device on proximal servers. This happens if connectivity companies, like telco companies, power their antennas with some limited computational resources. In this case, a direct use of the cloud is avoided, improving the overall management of resources, energy, and even security. This is a quote from Shakespeare. The original quote was "What's in a name?" about the rules, and in this case we have "What's in a name?" About the cloud. What could be cloud and what could be not a cloud? Actually, are cloud services provided by any customized resources. Of course, virtual machines that are instantiated on demand are, of course, cloud. Even geographically independent services are clouds, but above all, cloud services are characterized by only one approach to pay. It's the pay-as-you-go business. That means you don't need to buy your resources in advance, but if you need some resources, let's say one, because your business size is one, you have just to pay for one and fit with your business. As your business scale, you will scale even the computational resources. This is a nice figure that is a kind of standard way to represent the different kind of services in the cloud computing world. This is the upside down pyramid of cloud computing, where everything is a service. In the lower part of the upside down pyramid of cloud computing, we have the infrastructure as a service. In this case, the infrastructure, I mean what we usually feel as hardware, is considered just a service that could be allocated on demand or with other kind of policy. In this case, the main involved people are sys people that manage systems as system operator or similar. In this case, when the interaction is with instances, I mean servers that are configured and put in production with some software that is peculiar for a specific application. For example, we can power up really in a really light web server to host some web services on Amazon cloud infrastructure, paying only the time we need the machine be up, and even for free if we don't have too much traffic on this machine. The other level of the upside down pyramid of cloud computing is the platform as a service, PaaS. In this case, the heroes are the developers. That means that developers can use piece of code or better functionalities that are implemented on the cloud, very likely with an underlying infrastructure as a service, but without need to know any information about the kind of the infrastructure and even the parameter of scaling the infrastructure. Let's say if we are building a web service server using infrastructure as a service, we have to configure an auto-scaling system or another kind of technology in order to scale. For example, if we have, let's say, just numbers, 1,000 access per hour, we need just a really small virtual machine. But if we have millions or more than millions, 10 millions or 100 millions of requests in 1 hour, maybe we need more virtual machines that support in a scalable way the computational resource of the web server. Vice versa, if I consider the platform as a service, I could use a service that enable me to develop web services. In this case, I have just defined the access point, or better, the endpoint, and um, the access point and the code implementing each function. Then the underlying software leveraging an infrastructure as a service automatically scale and bill us, of course, if we have more or less requests in a 1 hour and minutes a second. Then finally, on the highest level of the upside down pyramid of cloud computing, we have the software as a service. Software as a service means a full, completely working application works in the way that leverage on platform as a service. But in this case, the users directly use the application without care about on which platform or better platforms as a service is leveraging on, and above all, without caring the real need of computation of the infrastructure. Some examples. We could consider platform as a service all the Google APIs, and software as a service all the Google Drive software, such as documents, slides, and so on. Really often the interaction with any level of the upside down cloud computing pyramid is done by a web browser in a really interactive way and friendly way, but above all for real production application using programmatically. That means using an API, application programming interface. As you can see on the right side of the slide, we have an arrow pointing up that is the value axis. As you go high in the upside down cloud computing pyramid, the value of the service rises. What are the pros, the good things of this good place that is the cloud computing world? First of all, as I told you a few slides ago, elasticity is one of the key words in cloud computing. Elasticity means I don't need to buy an infrastructure, I have to rent it, but above all, I have not to rent it statically, but I can just scale, making it more powerful on demand. That means on demand we can improve our performance and increase the computing power if we need, and or increase the storage size if we need, of course. But how is difficult? What is my effort to do that? In modern cloud computing stuff, everything is super easy, even too much, because it's easy to configure and start virtual machines, infrastructures, even complex infrastructure, and final users are completely decoupled by the infrastructure. They just interact with your application. That could be a mobile application, an IoT application, a machine learning application, an application that involves most parts of technologies we know, above all location services, for examples, but everything is scalable because you don't know when you start a new application how much computational resources you will need if your application will be successful, more or less successful. Above all, there's no need to buy, install, and configure the infrastructure. In this way, basically, you move what are the fixed costs to variable cost. And this is a key feature for the business. And above all, you don't care about the maintenance from the hardware point of view, of course, from the software point of view, it depends. If you use infrastructure as a service, you have to maintain your infrastructure from the software point of view. While if you need, if you use a platform as a service, you really don't care about any form of maintenance. Of course, as the value rises, even the cost of the service rises. But it's not true at all 100% because there are some exceptions that I will show you at the end of these slides. Oh, this is the most important slide for people that works with that are working on cloud computing, but even to the affordability, the business affordability of cloud computing. Uh, this class is definitely directed to master student. Master student means that you will manage and master the technical stuff, but even the management stuff. And this is a key slide for cloud computing because on the left side, you have the chart showing the relation between the total cost of ownership uh, and the on-premises configuration and on-cloud configuration over the time. How read the graph? On the X graph, we have the time. On the Y class, we have the cost in euros. On the vertical class, we have the cost in euros. The interception is when your business or your application start. Let's discuss the on-premises. On-premises means on your own property. That means if for your application you need a bunch of servers and some routers and some connectivity and some storage and whatever, you have to buy it. To buy it means you have an initial cost of investment. That's because on-prem has an interception with the vertical axis that is not zero. This is what you pay for your infrastructure. Then the cost of your infrastructure rise just because you have to pay the energy, the power, electricity to maintain your hardware. Let's compare the on-cloud approach. With the on-cloud approach, at beginning, you don't have investment cost, because you can order virtual resources as paying them as you go. And when that means that on cloud is every time better over on-prem. No, this is not true. We need to calculate the intercept where the two lines, the on-premises, or better, the two areas of cost, on-premises, non-cloud intercept. Because if your the time life of your application is on the left of the crossing, that means it's better to pay on cloud. If it is on the right, it's better to pay on-prem. Of course, it's not so simple because some other costs impact the cost of on-prem, and the cost of on-prem depends by the kind of application as the cost on cloud. So these are really simple model, but it's good enough for you to show this model. Let's now talk about the chart on the right side of the slide. Why is important elasticity? Let's say we have a variable business size along the year. This is really typical. Let's say this business in the example could be, for example, Amazon.com. Amazon.com, of course, has a peak during from the Thanksgiving to the first to January, because it's the Christmas season. Everybody want to buy a lot, and then the business sites decrease till August, where the most part in the Western world had the vacation, the school vacations. That means books are not so much sold, and even the technology. Usually, we buy technology when we are at home, not when we are in open air, and so on. So let's say this is the business side chart of Amazon, and this is the reason because Amazon released to the public their infrastructure as Amazon Web Services, because they need, in the first years of 2000, they need for a lot of computational power in order to don't be underpowered during the selling season, during the season between the Thanksgiving and the sales season in February. The point is two options were available, better three options were available. One just considering the minimum infrastructure cost, that means underpowered for the most part of the year, but save a lot of money. It was not good for the business. The other option is sites, the business, use the business styles, select the infrastructure cost as the average business size. In this way, you are averagely covered by the computing power. That means that you are overpowered during August and underpowered during December, February. And this is not admissible for a healthy business. So they used the brute force solution. They both they designed and implemented their infrastructure, setting it as the maximum business size. Of course, that means there are some months in the year that the Amazon business the Amazon infrastructure was overpowering the business, so they thought, okay, let's rent our infrastructure to other users. And this is the way Amazon Web Service was born. And it's incredible to say this is the reason, because you can watch all together Stranger Things last season without any problem in the streaming services. So in this class, continuously we will refer to two parameters that are typical to economy. Is the total cost of ownership, basically how does it cost my infrastructure, and the time to market. The time to market is the time between the idea and the application on the market. These two parameters are the dream and the dream and the nightmare of any people involved in computer science and computer engineering based business today. Costs. Why costs? As I told you, there's no need of initial investments. We don't have to pay for the infrastructure. Let's say during this class, each one of yours, or a group of yours, has an idea that could be a business idea. And that's the scenario. You don't have the initial money to invest in infrastructure, doesn't exist anymore, because you pay per use. If you need one server, you buy one server. If you need two servers, you buy two servers. If you need some services for machine learning, you pay just the time for computational machine learning. Let's just imagine how does it cost a GPU. One of the GPU we have in our machine costs about 16,000 euros, and each machine has 4 of them. So imagine it's a huge amount of money to do machine learning computation. So why don't rent this just for the time we need for our experiments? The other pros are the availability. There is a old excuse used by students at school. Oh, sorry, teacher, I cannot, I didn't my homework because the dog ate my notebook. That means a leaking of availability of your tools. This is nothing something that could be considered in the computer science related business. That means why redundancy, trust, data backup, and security are keyword in the availability of cloud computing services. The trust means what happens in the case my provider has a failure. This could happen. Imagine if you have a website, something really simple. Everybody has a website. On a public provider, this provider claims they are online 99.99% of the time. If you just multiply the number of hours in a year for the percent declared, you discovered you have many hours that is possible that your service is down. And this could be not considered as a possibility in the business of cloud computing because you need to be almost 100% up and running. And about the security, are your data really private? This is not something that could be considered in a really light way, because especially today with the GDPR, we have to design and develop our application strictly considered data of our users really private. And really if often we have some mermaids seeing really low costs in storage and computing for Eastern hosted clouds, but we cannot use this for data because we have to be sure all data is stored in the country where the user belongs to. One of the key technologies in cloud computing is virtualization, because cloud resources are virtual, and we could consider the cloud resources as infinitive computing. That means one upon a time, in 2000, one of the most focused research was scavenging unused computing resource to do some scientific calculation. Basically, the idea was, okay, your screensaver is on, that means your computer is doing nothing, and you have a Pentium with some megabytes of RAM, and you can share this computing power to do my calculations in finding aliens. This was the TETI project. But now the point is, and the scientist was looking for some resources. For example, I have to compute my my computation using a backpropagation network, and I need a CPU with some megabytes of RAM. Now the point of view is completely different. Now we ask to the cloud, I need on demand a virtual machine with, for example, 24 CPUs and 128 gigabytes of RAM and few terabytes of storage, because I have my machine learning software that have to be completed in a couple of weeks. Okay, some lot of money. But the virtual machine technology is a key technology, because without virtualization, cloud computing could be not possible. And the virtualization in cloud computing works thanks to a software component called hypervisor. The hypervisor enables the virtualization. It is also called a virtual machine monitor. We have many hypervisors. One of the oldest is Xen. Xen is a kernel level hypervisor, and it works on the root level, of course. It's open source, it works only in Linux. And Amazon Web Services has some customized version of SAN. VirtualBox is open source, is owned by Sun. It works on any platform, basically any platform, Linux, Windows, and Mac OS, and it runs at user level. This usually is very comfortable for who is learning cloud computing. Everything is running in at user level because it is easier to configure. KVM is another hypervisor. It works only on Linux and is at user level. VMware works on Linux, Windows, and Mac. Is a business software. It works very well and is at user level. We have even Parallels. Parallels work on Mac OS and is commercial, of course, and it works at user level. How it works, virtualization. We have some key concepts in virtualization. We have images. What is an image? An image is a persistent configuration of a virtual machine. Just imagine an image as a hard drive where you just install a clean version of iOS, of operating system, and the application you need. It's completely clean. No one have used it before, it's ready to use. On the other side, we have instances. An instance is an active virtual machine booted from an image. Of course, you could have only one image and boot from this image many instances. Each instance could be configured in a different way, but even each instance could be exactly the same and work or for scalability or even for trustness. For example, let image services that could be executed on odd numbers of time to be sure that the results is consistent. Another nice concept is a snapshot. It's a virtual machine that is freezed in a persistent state. That means you can snapshot a virtual machine, switch off, you don't pay this virtual machine, and then when you need again, you just power on, or better, recover from snapshot. And then finally we have appliances. An appliance is an application that is ready to use because it's installed on an image of a virtual machine and then installs it. Let's imagine, for example, we could have a super safe browser that is installed on a minimal version of a Linux and then summoned with its runtime only when we really need. In this case, we are pretty sure that nothing and nobody could access my real resources because we are working on a virtual machine in which there is only the browser. We are just using the browser. This is a new guy in the world of virtualization. New guy, that means few years. This is the operating system level virtualization. This is a smarter way to do virtualization using an approach called the split driver. Basically, each call of each library of a operating system is divided, that means split, in two sides, the backend and the front end. The backend runs on the actual machine, on the real machine, and the front end on the container is called. Basically, what is it? It's a virtual environment that works as a virtual machine, but it's not a virtual machine. It's not hardware virtualized. It's just software virtualized. And believe me, containers are super light. On your laptop, you can use Docker to run containers and experiment even custom clouds and application and website and web servers and whatever, just in a matter of a command line or a script command. Is a really powerful technology. The other big guy in cloud computing is storage, because we have a computing infrastructure and storage. Even muggles consider often cloud computing the same of storage. Let's just imagine Dropbox and iCloud and OneDrive and Google Drive, are basically all of them are file storage based clouds. That means operating file system is mocked by the cloud components, and the files data is stored as a POSIX file system. That means apparently you don't have real difference between how you deal with data on Dropbox or Google Drive and you deal with data on your hard drive. In this case, you can do some nice stuff as a synchronization between your local storage and the cloud storage. This is very powerful. Of course, we have some troubles in scalability because really often really complex file system with a huge tree of directories and subdirectory could be difficult to manage, but that is just technically, and definitely is really comfortable use this kind of cloud approach. There are some open source cloud file system, as everything is related with the MapReduce technologies. The block storage. Block storage is basically a virtual hard drive and have to be connected to a virtual machine instance. Imagine you have a virtual external drive with a virtual USB or other form of connection, and you physically connect the virtual hard drive to your virtual machine. Usually block storage is very, very fast. The performance are very good as real storage, even because really often are based on SS drive or even different level of storage, because different level of quality of storage. But you must have a virtual machine to connect a block storage unit. Really often many virtual storage block storage units are connected together to a virtual machine in a RAID fashion, exactly as a real hard drive. And this way, this virtual machine could export a file system. File system could be easily increased in size, just in more volume. So everything is very expensive in this way, but it's very performing. Then we have another kind of storage in the cloud. This is object storage. In this case, we have not structured data. We have only blob, binary large objects are identified by a URL. You can write and read. Definitely, that is good because you don't need a virtual machine to access it. You can access from everywhere in the world. It's really easy the replication because usually the object storage is replicated multiple times in different zones in order to have a better access or better performing access, but even for security and reliability. And the cons are, let's say you store image of 5 gigabytes on a block. That's perfectly possible. You cannot access data within the block. You have to download the block and access data and eventually update or better version the block. That's because really often a smart cloud application using the object storage encode data in the way that is friendly with the object storage, but above all friendly with the algorithms of retrieve and update this data. And finally, we have the last storage kind. There are databases in data warehouse. Are usually SQL and NoSQL. The use of the database server in the cloud is definitely convenient because really often we are biased by the fact to install on MongoDB or Maria SQL. We have just to cast a couple of commands on our Linux console. But this is good for, as a toy, it's not good as a production. In production, you need some scalability and security stuff, and this is completely already available by services on the cloud that offer SQL and NoSQL databases. Another keyword, auto-scaling. The auto-scaling is is a mechanism that stretch computing and storage resources as your business needs for more or less power. Usually this is done by software called the load balancer, applying a load balancing algorithm. Really often you can customize the load balancing algorithm in order to fit your business, and it's based on metrics. Really often again, the cost management is related to load balancing because, of course, we can just imagine that if we scale the infrastructure, you have a better performance for your business. But there is even the cost management because maybe this performance are not balanced by increment of the of your business profitability. Almost at the beginning of the presentation, I told you, yes, it's super easy to set up a web service provider using infrastructure as a service, but this is a very naive way, and in a real production environment could be not so cheap as expected. And microservices and Lambda functions exactly help us in this kind of problem solving. In particular, microservices are really simple and lightweight services offering functionalities in the way an application could be made joining multiple services. It's a very productive way, even because this is easy to develop and easy to scale. In this way, we have a real time to market minimization because once we have an idea with some libraries of microservices connected in the way that our idea is prototypically working, we already have something that could be used to test if the idea is good for the market or not. And then finally, an application that is based on microservices is really easy to maintain, update, and upgrade because just to interact with the small part of the code each time you have to change something. Finally, directly connected with the microservices are the Lambda functions. Lambda functions are some piece of code that are executed when the endpoint of a microservice is involved. This part of the code runs in a server, but you are billed on the computational resources used by the code execution, not by the server standing up. That means, let's say you have a Lambda that, for example, provide some weather information if an Alexa user asks for weather to a dot device, to an Alexa-enabled device. You don't have to pay for 24 hours, 7 days server that have to be up and running. You have to pay just for how much the user invoke your Alexa skill that invoke your Lambda function. In this case, we have just to provide the code usually in Python or Node.js in the user interface of the cloud provider on your SDK, and then deploy your package, and the cloud will make the rest. Just to conclude this first presentation, I remember you this book, and since the next time you will start with a more detailed lectures about storage from this book. And for curious people that want to be productive in a really practical way, I suggest this learning material in Italian. Of course, this class is new, and all the teaching material is in theory and will be provided to the students. Thank you for the attention.